Hope there is no disturbance in the session, right? Okay. Okay. So today we'll be solving some problems on the topics where we have covered till now, right? I need to move my chair. Okay, it's quite good now. So we'll be going through with some of the problems, right? So n queens lead code. Let us go with this problem, right? This is the hard problem. Let us see. Let us see what is given in this problem and let us see how can we solve it. The n queens puzzle is the problem of placing n queens on an n by n chessboard such that no two queens attack each other. Right? Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the n queens placement where Q and dot both indicate a queen and an empty space respectively. So this chessboard is not given like a array of integers. Instead, it is given as array of, I think, strings, right? Vector of vector strings. Let me tell you what does it mean, right? First, we are having this one as a string, and then this one as the second string, and this one as the third, and this one as the fourth, right? So we are given with n, just n, but we need to return the chessboard with queens. It is okay that I can understand this is a hard problem, but let us see how can we solve this. But I am thinking like, why do we need vector of string inside? Isn't the uh, vector of vector string, why a 2D string matrix is needed? Because here we are representing it, okay, right? The first one, let us see, to the four queens puzzle as shown above. Okay, so if you see, this is one possibility and this is another possibility to place queens. So that's how we got these two. This is the first array of string, and this is the next array of string, right? I think it's clear for you. If you have any doubts, please let me know in the chat box. We'll be solving this, right? We have understood what is the problem about. Now let us see what are the constants. So n can be till 9. Let us see how can we solve this, but the constants are like n can be till from 1 to 9. Okay, so let us see how can we solve this, right, by taking n is equal to 4 first, right? I think it makes sense. So what are they asking is what they gave and what are they asking for, right? Okay, okay. First thing, what are they given with? Given n, return the possible possible uh, possible places, possible ways of placing n queens. That's what the question is about. N queens on a n by n grid. N by n grid. So it is not just that we need to return the number, but instead we have to return how the grid will look like. I'll tell you how we represent the grid. So let us take this queen symbol like this. Okay, we have got this queen symbol. So in an n by n grid, so we need to place n queens. And what are the possibilities? That possible ways we need to include in a vector of string. I'll tell you how. First thing, let us draw this queen. Okay, so this is how our queen is, right? So what is the grid size? Let us take the first example of n is equal to 4. So the n value is 4. Now, given and written all distant solutions to n queens puzzle, you may return such that no two queens attack each other, right? How does a queen attack, in chessboard? If you don't know, let me tell you, right? I think everyone knows that. So the queen attacks in all the possible directions, like 8 directions. Front or row wise, sorry, column wise up and down, right, left, diagonally, top right, top left, bottom, bottom right. So how many directions is it going with? It can go in top, it can go in right, it can go by down, it can go by left, it can go diagonally, uh, top right or bottom left, it can go top left and bottom right. So it can go in 8 different directions, right? So if I place a queen here, then I cannot place a queen at this place. So it is not possible, right? Now, if I placed a queen here, I cannot place a queen here. If I placed a queen, no placing a queen here. I cannot place here. I cannot place here or here. So I need some ways to place this queen. Imagine if I placed the queen here. Now, at this cell, there are something like these many cells. So, what are the cells that I cannot place, right? Are there any places that I cannot place? Let me tell you that all the cells which are to the top are neglected. So top, bottom, left, right, top left, bottom, bottom right. So let's cancel all those cells. This cell is cancelled, this one cancelled, this one is also cancelled, this one is also cancelled, this one, and then this one, this one. If there is another cell here, that one also will be cancelled. That means it is not possible to place a queen here. I cannot place here, I cannot place here, but there are two possibilities. I can place the queen here. I can place a queen here. Now I can place the another queen here. But if you see, is it difficult or easy to get the, you know, the possible positions, or the, what do you say, the wrong positions, wrong cells, invalid cells. So to get the invalid cells is much easier. We just need to check the 8 directions, right? So it is, let me write it. It is much easier to check the 8 directions where placing a queen is invalid. So it is, as it is easy, we will check all these uh, places and we will not place our queen there. Right. Now, what if, what if I start by n is equal to 4? Now, firstly, we will start with the grade of n by n, nothing but 4 by 4. Let us see how can we solve this. N by n. So the first thing which I am doing is let me write it. Every row should have a queen, and every column should have a queen. So that's what it was asked here. So every row is having a queen. If you see, all the 4 rows is having a queen. All the 4 columns is also having a queen. Same here. Every row is having a queen, and also every column is also having a queen, right? So that's what I wrote here. Every row should have a queen, and every column also should have a queen. Now what I'll do, I'll just place a dot instead of starting with, queens. I'm placing dots here. I don't know whether this is the right way to approach the problem, but let me just go with how I would look at this, right? So I am placing all dots, right? Now I'll place a Q here, right? So if I placed a Q, I'll check this. This I'll check with top. Is there any top? No. Right. Is there any right? No. Is there any top right? No. Is there any bottom right? No. Is there any bottom? You know, if I check these bottom right, it will take much time. I'm just assuming. Why? Because these are not even placed with any queens, right? So what I'll do, I'll just check only the top things, nothing but top, top right, right, left, top left. Only these 5 are enough. Why? Because we are starting from the top, right? We are starting from Q here. We are not going from end, this placing Q here, so that if we are at this point, we need to check whether there is a queen here. So that's why let us just check right, left, top, top right, and top left. Only 5 directions. Now I'm at this position. Check top. No. Check right. Top right. No. Check right. There is no queen here. Check top left. No. There is no cells. Check left. I have a Q. So it is not valid. Let's go here. Uh, okay. Let's go to this point. Check top. No. Check top right. No. Right. There are no queens. Top left. No cells. Left. I have a Q. So this is not valid. Now, at this point, when you are at this dot, check top, no points, no cells actually, top right, no cells actually, top, sorry, right, no cells, top left, no cells, a Q on the left. So this is also not valid. Now, when I get to this dot, I'll just check top. So this is not valid here itself. At this point, check left. There is no queen. But check top left, I have a queen. So this is not valid. At this time, check top, top right, right, left, and diagonally top left. Do you see any queen? No. So what I'll do, uh, place, I'll just place a queen here. Let us see what happens. Now, after placing a queen, let's go to the next point. Here, check top, no, no queen. Check top right, no queen. Check right, no queen. Top left, no queen. Left, there is a queen. So this is not valid, however. Now, let us go to the next. Here, check top. Do I have a queen? Yes, I have. Here, check top. Do I have a queen? No. Check top right. Do I have a queen? Yes. So this is not valid. At this point, check top. Do I have a queen? Yes. So this is not valid place to valid cell to place a queen. At this point, check top. Do you see any queen? No. Check top left. I see a queen. But if you see, I went through this row, but I didn't place any queen. Now what I will do is I will just go here and I will just backtrack. Now instead of placing this over here, do I have something like, can I place it here? I can even place it here if I didn't place it this queen at this point. So let us do that. Instead of placing this Q here, so I will place it here. Now, let us check again at this Q, at this cell. Do I have a Q on the top? Yes, do I have a Q on the top? It is not valid. At this cell, do I have a Q on the top? No. At the top right? No. On the right? No. On the left? No. On the top left? No. So it is valid actually. Let me place that Q here. Let us see. Next, so let us go to the next row. Why? Because if you see, when I can't place a queen here, I went to the previous queen, I went to the previous row and just said to backtrack. So the place which you are at, it is not a valid cell. So just move one cell forward or another cells, right? So that's how I went from this cell to this cell with the Q. Now let us go with another cells. So when I place a queen on a row, I'll just go to the next row. At this point or cell, do I have a queen on the top? Yes, I do have. So skip it. It is not valid. Do I have a queen on the top? Yes. So skip it because it is not valid. Do I have a queen on the top? No. On top right? No. Right? No. Left? No. But top left I do have. So it is not valid place. I hope this will be Q, but let us see. Do I have a queen on the top? Yes. This is also not valid. Then the same thing again. No queen on this row. As I said, every row should have a queen. What we will do? We'll just check whether here we have placed previously, right? We will go to this cell. Now, do I have a queen on the top? No. On left, top left? No. Top right, I have a queen. So it is not a valid place. At this point, do I have a queen on the top? Yes. So it is not valid. Now what I'll do is I'll just backtrack again. Why? Because this row is not having queen. So what I'll do, I'll just backtrack again to this point. This Q need to move forward. But do I have any cell after that? No. So this place is not valid for the Q. This will also backtrack to this Q and then this Q will go here. Now let us start with our queens again, right? So at this point, do I have a queen on the top? No. On the top right? Yes. So this is not valid. At this point, or cell, do I have a queen on the top? Yes. So it is not valid. At this point, do I have a queen on the top? No. Top left I have, so this is not valid. At this point, on top I don't have, on right I don't even have cells, on top right I don't even have cells, on left I don't have any queen, on top left on diagonally no queens. So this is actually a valid queen. Now at this point, do I have a queen on the top? No. On top right? No. Right? No. Left? No. Top left? No. So, excuse me. So, we can place a queue here. Next, go to the next row immediately. Now, do I have a queen on the top? Yes. So, it is not valid. Do I have a queen on the top? No. Top left? Yes. So, it is not valid. On top? No. On top right? No. On right? No. On top left? It will go to this cell. Do I have a queen here? No. Do I have a queen here? No. And then no. No cells. On left, do I have a queen? No. So this is a valid cell, right? So this is one possibility, but it is not enough for me. Why? Because what if I just place a queen here and that too even possible, right? So what I'll do, I'll just start again. So that's one possibility. Let's go with another possibility by the same 4 by 4 uh, grid. Okay. Now everything is a dot, right? We'll be filling it with dots. Okay. Let us see. But before starting, let me know in the comment section if you have any doubts, right? I think I'm audible for you. Another possibility. Yes. So, firstly, here I stopped the queen placing at this point. So what if I placed here? Alright, so that's what I'll do. I'll place it here. Now on top, do I have any queens? No. On top right? No. On right? No. On left? No cells. Even on top left no cells, and on left no cells. So if you see, this is a perfect place to place a queen, perfect cell to place a queen, right? So there are no queen to attack this queen. Now on the next row, let me go to this cell. Do I have a queen on the top? Yes. So it is not valid. On top? No. On right? Not top right. On top left, I have a queen. So this queens will attack. So I'll not place it here. So let me check this point. Do I have on the top? No. Top right? No. Right? No. Left? No. Sorry. On top, I have a queen. Sorry for this mistake. So I have a queen on the top, so it is not valid, right? So at this point, let us look at this cell. On top, I don't have any queens. On right, top right, no cells even. Right, no cells even. On diagonal, top left, no queens. On left, no queens. If you see, this cell is a uh, perfect cell to place a queen, so that no queen, these two queens will not attack this queen. So it is a perfect cell to place our queen. Now on top I have a queen, so is it valid? No. On top, do I have any queen? No. On top right? No. On right? No. On top left? No. On left? No. So there is no queen to attack at this cell, so we can place a queen on that cell. So we have placed it and we will return these strings, vector of strings. This is one vector of string. I'll tell you how. Dot dot q dot comma uh, q dot 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 and then dot 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 q and then dot q dot dot. So this is one array, and the next array will be this one, dot q dot 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 q dot dot, then triple dot q q triple dot and then dot q dot q dot. Okay, these are the two possibilities, or only two possibilities, so that we can place the queens, right? So I think it's clear for you, but you can try, or let me try it. However, let us try placing the first queen at column 4. You might be having the doubt. We have started with with placing at cell 1, cell 2 and cell 3, but we didn't place it at cell 4. So Q will be placed here. Here, can I place it over here? So no, no, no. So I can place it over here. Now, can I place it over here? No. Can I place it over here? No. Can I place it over here? Yes, I can place it over here. Now, can I place it over here? No. Why? Because this will attack. Can I place it over here? No. Why? Because this will attack. Excuse me. Can I place it over here? Why? Because no. Why? Because this will attack. Can I place it over here? No. Why? Because this will attack, or this will attack. So this is not possible. Let us backtrack and place it over here. But if I place it over here, this will attack. So there is no possibility. So backtrack. Now can I place it over here? Yes, because there is no uh, queen to attack. But can I place it over here? No. Why? Because this will attack. So can I place it over here? No. Why? Because this will attack. So this queen is not possible here. Can I place it over here? No, because this queen will attack. Can I place it over here? No, because this queen will attack. So there is no possibility. So this queen cannot be placed at this place. It is not possible. Right. We got two string vector of strings. We will return this in vector of vector string. That's why we are given with vector of vector string, right? I think it's clear for you, right? This will be the problem we'll be solving today, but we will come again tomorrow. This is just a practice live session, right? uh, However, we have chosen n queens problem, which is a hard problem, right? Okay, if you have any doubts, please let me know in the chat box. Let us solve this by the code. So we need to write the code, however, in the last. Right. First thing, what if n is equal to 2 or n is equal to 3? Let us start solving it. If I place a q, I need to place a q here or here. So both are not valid. So remove it. We just return an empty vector of string here at n is equal to 2. Now if n is equal to 3, I'll place it here, but I need to place here, here or here. Let us place it over here, but I cannot place it here or here or here. So let me place it over here. I cannot place in three places. Now if I place it over here, I cannot place here, here or here. If I place it, then I cannot place it here. So if n is equal to 3, then we will also return an empty vector of vector string. Now, if n is equal to 1, we'll just return okay, this is just right, only one queen on one cell, that's it. So let me write the algorithm for you. N is equal to 2, n is equal to 2 or n is equal to 3, return an empty vector of vector string. Now, if not n is equal to 1, then we will return just a string like this. Now, if not, we'll just create a string s of size n, just a dot. Why? Because as I said, the string will have this, right? Only, dot dot q dot, right? Okay, we have string s as n comma dot right here. Now, uh, let us do one thing. We have only one string. We have only one row. We need how many rows like this? We need n rows like that. So what we'll do, we'll just create vector of string, name it as grid of what is the size of the grid n, and what are the strings? Every string is s itself with dots. Now we'll just call the function backtrack. What is the starting row? Will however send grid will be starting with the row 0 and the last one is just n, right? It is the boundary. So we'll be returning the answer at the end. But to return the answer, we need to know what is the answer. So answer is nothing but vector of vector string answer. First thing, first thing is I need to know uh, whether a position is valid or not. So we'll write a bool function is valid. What are the things which we will be, you know, will be going through? I'll tell you afterwards, but let's go with the backtrack function. What is the base case when you are starting with this grid 0 and then n? If you see, I started with 0, but it is not 0. It should be, I think, a row, right? Yes, we are starting with 0, nothing but the row. So we need to fill every row with a queen. So the row will be starting with 0, right? And then I have n. Now, if row is equal to n, answer dot push back the grid and return there itself. This will be a void function, right? So if row is equal to n, nothing but we have filled all the rows of the grid. So it is a valid, valid pixel boundary. Hi, brother. Thanks for joining the live session. So if you have any doubts, please let me know in the comment section. So we are solving the n queens problem today. Okay, so we will return there itself, nothing but all the rows are filled, so this grid is valid. That's why I'm pushing this grid into answer and then returning there itself. Now I'll write a for loop for I is equal to 0, I is less than n, I plus plus if this is valid. Now this row nothing but the column, I is nothing but the column, and the grid. I'll check all the previous strings whether is it valid. If it is valid, grid of the row and the column. If you see, this is the row and the column is nothing but the I. I will be iterating from 0, 1, 2, 3 and less than n, right? Now, grid of row I, here I will place Q. Okay, now after that I will just go with backtrack. I'll just call for backtrack function with grid and then row plus 1 comma n, then grid of row I is equal to dot again. So here if you see, I am placing a queen there and then I am just removing that queen at that place. However, why? Because if the queen is not valid at that cell, we need to go to the next cell. So if it is not valid, we need to make it as a dot, right? So let us write the is valid function. So in the is valid function, I have row and column. So row, column, and have the grid. So this is a vector of string. Now first I need to go upwards. Now if you see, do I have to check the right and left? Why? Because I'm placing only one queen in one row. So the code will not return any queen on the same row. Excuse me. So I just need to check top, top right, top left, top, top right, and top left. Let us check for top. So I'll start if I am at I is equal to row. I'll go while I is greater than or equal to 0 and I minus minus. Right? If I am at this point, I need to go to the starting point. Nothing but this row need to be decremented. So if grid of the I, nothing but the row, and the column, here we are given with the column, is equal to queen if it is already placed, then a queen is already placed at that point, then will return false. Why? Because that queen will attack. Now let's go with top right. Now I is greater than or is equal to 0. Let's start with our top right. Okay, we are with here I and then j. So if I take this like 3 comma 3, so here it will be 2 3 1 0. Now uh, here it will be 3 comma 3 1 2 3, and this will be these things 3 2 3 3 and 4. Now how do I go to the right? So I'm just decrementing I but incrementing j. Okay, I will be our row and j will be the column, I think. Okay, let us see. So the I is equal to the current row which we are at row and j will be the column. While I is greater than or equal to 0, I will be decrementing as I said, and j is less than grid dot size. Let us do a while loop on this, and if grid of I j is equal to q, then return false there itself, right? Now top left, I is equal to row and j is equal to column, while I is greater than or equal to 0, j is also greater than or equal to 0. Why? Because all the I and j will be decremented when we are going top left. So if grid of I j is equal to queen, so return false, there itself. We have checked all the three things. After that, if those are not you know returning false, at the end return true. So this is how you solve this problem, and I think let us okay, I think it's clear for you, but we need to do the code part for this. Let me do the code part. First, let me write a vector of vector string answer, vector of vector string answer, sorry, answer bool is valid with int row, int column, and vector of string ampersand grid. Don't miss this ampersand. Why? Because it will not change the values. It will just take the values and do the operation in the functions. That's it. It will just execute the statements, but it will not change the grid. So for int I is equal to row, I is greater than or equal to 0, I minus minus. If grid of I and column is equal to a queen, then return false there itself. Sorry. After that, int I is equal to row, j is equal to column. While I is greater than or equal to 0 and j is less than, sorry, j is less than grid dot size, if grid of I and j, grid ij is equal to q, then return false. Sorry, return false. I think that's enough. And I no. No need of again slicing I is equal to all row and j is equal to column. Right? Okay. So while I is greater than or equal to 0 and j is greater than or equal to 0, if grid of I and j is equal to queen, then return false. At the last, return true. Now, this is the function of is valid. But what about backtrack? So here we'll be using a void. We'll be not we'll be returning nothing in this function. So backtrack vector of string person grid int int row int n. First, if row is equal to n, answer dot push back grid and return the itself. For int I is equal to 0, I is less than I plus plus. If is valid row comma I comma grid. So at this point, if it is valid grid of row and I is equal to q, then backtrack again with grid and row plus 1 comma n, then grid of row and the column is nothing but I is again made a dot. But if you see, yes, that's it. Okay, we'll return at the end. Now in the main function, as I mentioned before, if n is equal to 2 or n is equal to 3, return empty strings, empty vector of vector string. If n is equal to 1, return like this. Now just build string s of n comma dot vector of string grid of n comma s. Now backtrack grid of 0 comma n. Now at the last return answer. Sorry, it should be semicolon. Instead I returned L. Let me run that again. I hope there will be no errors. Okay, the output is empty. Return vector of vector string answer. I think everything is correct, right? Okay. So if you see, I'm not incrementing or decrementing the pointers here. I is greater than or equal to 0. So I minus minus. J is less than grid dot size. So J plus plus. Here I minus minus and sorry J minus minus. Okay. Okay. So that's the small mistake which I did. So I shouldn't be having did that. So let me just change it here. So we need to increment and decrement these I and j pointers. So I greater than or equal to 0. So I minus minus and j plus plus here. Now in this while loop, I minus minus and j minus minus. So this is how we solve this. Let me submit it. I hope it runs on all test cases. However, we'll be having till 9. No. If n is equal to 2, we got, no, we need to return like this. Okay. So why don't we, instead of, uh, you know, doing this, let us do one thing. Test case. We just add one test case. Let us add 5 and then 6 and here 7 and here 8 and here 9. So if this is something like, we mostly don't get this type of test cases or constraints, well, because the constraints are low, that's why I just did it. So this is today's live session. There will be 10 minutes more time till 10:15. So if you have any doubts, please let me know in the comment section. And I am also starting, you know, DSA mentorship sessions every Saturday, right? So if you have interest, you can join there, right? So I'll be sharing you the link in the description. Go and check it. So, and you have to just fill the form, and there will be installment wise, or you can just pay all your amount once. So that's how it will be, right? So we'll be having sessions every week, right? Every Saturday. Hi, bro. Furious. Know your name. It is YT in you on EYT. Furious one YouTube. Okay. Sorry for mispronouncing your name, bro. Hi, brother. How are you doing? Right. If you have any doubts, let me know in this. I don't know how DSA works. Okay. So I think you need to start DSA, or you need to know what is this DSA, right? So this DSA, like if you see here, this problem is based on how can you place a queen, right? Queen, placing n queens. But using this, we can also write codes for all those winning strategies, winning strategies in chess, or there is thing like game theory. This is something like a code forces topic. How to start, bro? Will be have also given the, you know, what do you say, roadmap in my Instagram page, so you can follow me, r_s_s1111. So you can follow me there, and you will be getting the roadmap there itself. And if you want a full roadmap or every problem, you see, on week wise what problems you need to do, so you can just follow me in LinkedIn. Just search for this /in linkedin.com. So you can send me a request here or follow me in underscore in this is Instagram page, Instagram profile. So you can contact me there or you can contact me here, right? So I have just started with what are the different approaches in it, how to use those approaches. So brother, we'll be having data structures, nothing but arrays, and something like trees, hash map, and also there are many things like graphs, binary trees, and all these are data structures, right? There are something like heap, right? Now imagine you want all your elements to be sorted in higher to lower, right? So we'll be using a heap at that time. Now if you want all the elements to be sorted in, you know, in an order, so we'll be using a set. Here it will be like heap is nothing but like this. You see a heap, it will be like this, but we can also get a heap like this will be also a heap, right? There will be max heap and min heap. So this is how data structures will be. Now there are algorithms like KMP algorithm. That's the algorithm which I knew. And there are also prefix sum algorithm, and many algorithms like this cadence algorithm like these. So by taking these help of these algorithms, we can implement the problem, we can solve a problem by using these data structure, sorry data structures. So in data structures, we will be storing the data or elements, you know, different data types like a string or a integer, or if, you know, all this float, long, all these data types elements will be stored in a data structure. So, having only like a data structure like this will be like not efficient in a programming language. There will be something like linked list, and in that linked list we'll be having a doubly linked list, right? So like this, a doubly linked list, and there will be circular linked list like this. These are the data structures, right? If you have any doubts, let me know. I think your doubt was cleared, brother. So we'll be solving like that, and you can get it once you start solving it. You can follow these Instagram pages. I'll be sharing you Instagram profile. I'll be sharing with you with YouTube live, and also with, I have also started the 25 members mentorship batch. So these sessions will be of cost of 6,000 for 6 months. Every Saturday, we'll be having a nothing but a 25 batch live class, right? Now, if you have a friend or you want to refer that friend about this course, you will get it for 5,000 only. So if you want, you can just contact me or just comment. I'll be giving you the link. So you can just contact me in this LinkedIn profile, or you can just follow me in this Instagram. Bro, how to get logic building? Bro, there is something like, if you are a beginner, so there are something like patterns, pattern problems, right? So these patterns like print a star like this, only first line 1 star and second line 2 star and third line 3 stars. So that's the basic thing. After patterns, do something like easy problems in any, any coding platform. I preferred a lead code when I started. You can also prefer code forces, code chef, or edcoder, anything. I think edcoder, I don't know how, I didn't use edcoder before, but I heard about it. So you can use lead code, code forces, code chef, edcoder. But the logic building can be built only when you practice more. Nothing but it is nothing but, if you see, you know uh, there will be problems in integration and differentiation. How do you get the logic of doing or solving a integration problem or differentiation problem? First 10 problems, if you give you the 11th problem, it might be hard. But if you have solved 100 problems, and if you are given, want to write an exam on 10 questions, you might solve 8 problems on it. So practice makes you much perfect in logic building. That's what I believe. So when you solve as much as problems, then you can go with the logic building. Logic building isn't a thing if you have solved many mm, many problems, right? Now in interviews, what it happens like, they don't want you to completely, you know solve the problem itself and get the code accepted. They need the approach, how you think, or how good you will go with the logic building, right? It is not right, directly write the code for this so that it will get accepted, not like that. It will be just like logic building. How is your approach? How are you thinking about the problem? That's how it goes, right? I think it's clear for you. We'll be we'll be having a session again, right? So if you have any doubts, let me know in the comment section, and please don't forget to get to these things. If you have any doubts, or you don't have much time, or you want to ask more doubts, it's not like if you only pay this 6,000 I will be clearing your doubts. No, nothing like that. I can also help you through roadmap, something like it. But if you want live classes on, and also discuss deeply about a DSA, you need to take this course. If you refer a person, both of you will get 5,000 as mentorship, right? So there will be only 25 members in the class every Saturday. It will be much helpful for you. So we will be also maintaining a streak and also contest problems, right? So that's how it will be. It will be much helpful for you. Let me give you the link. So if anyone is interested to join the sessions from this Saturday, you can just click the link and fill the form. I'll be reaching out to you, right? Okay. So if you have any doubts, please let me know in the comment section. We'll be ending this session in 3 minutes. At 10:20 we'll be ending this session, but if you have any doubts, let me know in the comment section. So that's how it will be, the DSA course. But if you want to build the logic, I think your doubt is clear, Shiva Narayana, right? So to build your logic, you need to concentrate on solving problems. But when you solve the problem, don't just like want to get the code submitted or need to have more problems in my profile. Not like that. If you are solving a problem, solve it like you don't need to come again to the problem again, right? So if you are solving a problem, make sure that you don't forget. I'm not saying that to memorize it, but please make sure that you understand the problem and also the concept and the thought process. If you have any thoughts or even the wrong approach, please note it down in your notebook or any notes, so that you don't forget how you thought first, and then what was your thought process, how you developed your thinking process, right? So it will be much helpful for you if you maintain a notes, right? Everyone does it. If you have any notes, let me know in the comment section. We'll be ending this session soon in 5 minutes. Right, okay. We have solved this question just now, and it took around 40 minutes, I think. Yes, it took around 40 minutes. So when you open the lead code problems, right? Let me tell you. So if you open the lead code and let us go with the problems now. So sorted by custom, but I am sorting it by acceptance rate. So all the mostly accepted or the easy problems are on the top. Now I am just filtering it out. Status is to do. What do I need? If you want to revise it, then you can just go with solved, right? So all the solved problems will be here. All the to do problems will be here, right? All the to do problems, and difficulty is, if you want to solve easy and also medium problems, then you can set that thing. And topics is, I want to solve on array and also string. Is there anything? Okay, let's just select these. Now I'll go with all the problems. If you see, all these are easy problems, mostly accepted problems, right? So this makes you easier for this makes easier for you to understand a topic. So select a topic and just go with the problems there and increase the acceptance rate. Now, once you get these acceptance rate, just go with go with these topics, difficulty, easy, medium, and also you can try out hard problems also, right? So we can get hard problems. Let me tell you. Okay, I'm just removing easy and medium. So all the hard problems are here with array and string. These are the only topics which I have selected. So this is about today's session. I think most of the doubts were clear. If you have any doubts, let me know in the comment section. We'll be ending this session in 4 minutes. And don't forget to follow me in LinkedIn, right? You will be getting all those updates in LinkedIn, and also Insta profile. That's just a profile note. I didn't launch any page till now. Okay. Right, I think there are no doubts for you. However, we'll be ending this at 10:25. Yes. Okay, if you have any doubts, let me know. Without wasting our time, we can just go with any doubts. You can also, ask those questions which you get in the mind about DSA, right? So let me know which year are you studying in. I need to know whether which year are you or which where are you from, right? Okay, we'll be ending this session in 1 minute. Let me tell you that at 10:25 we'll be ending this session. So if you have any doubts, you can contact me in LinkedIn or Insta, or you can just comment in the comment section, right? Okay.